Okay, so welcome to this video. What is this video about? This video is building on the smart contract series we've been doing to show you how to write a contract. Now, when I say write a contract, it would take a very, very long time if we went over every single bit and you saw me typing out every bit. So I am going to do a little bit of here's one I made earlier and drop code in, but hopefully it will be instructive enough that you'll see what's going on. So a reminder of what we did in our previous tutorials. We did a couple on instantiating, interacting with messages, that sort of thing. And in the last one, in the anatomy of a smart contract, we talked about how there's essentially three main components of a CosmWasm smart contract, right? Messaging, state, and queries. So messaging, we talked about them being sort of like a write to state, which is kind of like a database or a file system, and then querying, which is kind of like a read back out from that. And we're going to see all three of those things in action. So what we're going to do in this is we're going to take the EIP 2981 emerging standard for royalties, and we're going to add that royalty info message to CW 721. And for the purposes of doing this quickly, we're also not going to really do much by way of changing the original contract code. We're just going to bring it in pretty much wholesale and extend it, okay, from CosmWasm Plus, which is where the CW 721 code lives, okay? But first we need to generate our new project. So we're going to do that here. We're going to use this cargo generate command with the template, which will bring in the most recent one. And we're going to call it CW2981 contract wide. So this first one we're going to implement, so the EIP standard, at least as I understand it, says that you can set the royalty info at token level, or you can set it at contract level. So in the first instance, we're actually going to set it at contract level, and later I'll probably go back and write one for token level royalty implementation. So anyway, let's do that. Sensational. So that's been built. So let's go to, and it's initialized a Git repository. Right, so I'm now going to open that in my edit, and we're going to open it in Sublime in this case because I can make it nice and big, and I'll see you back here in a minute. Okay, so the first thing we're going to do is just fill in all the stuff we need in Cargo Toml. So I've actually changed this a little bit from what comes with the package because ultimately, I suppose some of this code might be refactored and end up going back towards the direction of CosmWasm Plus. So I've kind of moved I've set the version as 0.8.1 because it's based on the 0.8.1 code and packages there, although normally if you're using semantic versioning you might call this 0.1.0 or 0.0.1 even, as well as specifying description and license and that sort of thing, and then I'm just going to go drop in the code into the right places, and I'll show you what that looks like in a second. Okay, so to give you an idea of what we've changed the schema.rs file, so that generates the JSON schemas. We've changed the contract code. We've added the errors to errors. We haven't. That's lib. Hang on a minute. Hang on a second. Let's get this right. So that looks like a lib file. So that should be in lib, which is going to be exactly the same. Message, we need to actually add the code to message. So let's do that now. State, and we've added Emacs to the git ignore. Okay, so now what we should be able to do, if all has gone well, is build the project. This will mean that Sublime will I know what's happened here. This is a classic copy paste fail. So let's go back. we've got a bunch of things here that have a path, because in they've been copied. This is my fault for copy and pasting. They obviously are a relative path in CosmWasm plus, so they are brought in from there, but we want to bring them in from package manager, so we just need to remove those. This is seat of your pants type stuff. Now it should cargo build. So this is just that building this mainly, obviously you would use CosmWasm to build it normally, or build an optimized build, but this will mean the editor can pick it up. And we can also run unit tests, and we can also build the schemas, which we'll do just to check everything's working. Oh, it does not like that. Why does it not like that? We didn't include CW721 base. Oh, it's because we've obviously renamed things. So let's go to schema.rs, and our project is called, what's our project called? CW2981 contract wide. And let's just double check that. Yeah, that should be right. So let's try that again. And that time it worked. Okay, cool. And then if we just do unit test should pass, hopefully. Yeah, test pass. Okay, so the project's working. We've imported all the code. It's all compiling. Now we can make our changes. Okay, so we're going to go through this more or less in the shape that we described in the previous video. We're going to deal with messages, then state, then our querying, and we've got query messages defined here as well though, so we'll define our messages and our query messages at the same time. Because we're doing this, so EIP 2981, at least as I understand it, can be defined at token level or at contract level. This time we're doing it at contract level because it's simpler, and this video can't be 1,000 years long. So we need to define some parameters at instantiation time to govern the royalty percentage, essentially. So we're going to quickly do that. Note that this isn't necessarily correct in terms of types and stuff. They're the types that will line up and compile, but there's usually with strongly typed languages, to be fair, there is one correct answer, but your opinion as to whether I'm typing everything correctly might be slightly different, and yeah, you might be right. Like I say, haven't overly thought about this, but other than looking at the spec and going, okay, what's the minimum we need to do? So we're going to, just as a kind of clear indicator of what's going on here, I've just prefixed all of these with the word royalty. You could also put this as a nested struct or something if you wanted to. That would also be completely valid. So the other two, so those are going to be written at instantiation time, and we'll define that in state in a second. And then in query messaging, so there's nothing that needs doing to execute message because we'll define that instantiation time. In terms of query message, we're going to need to define two more queries. We're going to need to basically be able to look up royalty info at the time of sale. So recall that 721 defines a transfer, but it's up to the marketplace to implement the actual payment. So at the time of transfer, we don't say you must pay a royalty. We're relying on the marketplace to query whether or not a royalty is owed. Okay, and then there's also a second function called check royalties, which is simply whether or not this contract implements royalties and they should be paid. If you had token level royalties, I guess the check royalties function would be at token level. It's not 100% clear to me about that one. I just assume so. That's the granularity it should work at. Okay, so we've dropped in those 2 query messages. When we save this, it's probably going to error. Yeah, it's going to error. Good. So have we got anything else from standard in there? Not yet. So, oh, yes, we do. Binary. That's cool. That will stop it complaining. Okay, and now we're going to define those query messages in line with the spec. So this is going to return an address and a royalty amount, which is a coin. So it's important as well that the okay, so let's just quickly go back up to this query we just defined. So it's important here, this is a token ID and sale price. It's important, and this comment pulls that out, is that royalties, that coin should have the same denomination. And we'll see in the implementation that we get around that in a kind of easy way. So, but it's agnostic of denomination, right? So it's up to the thing that's doing the sale in a denomination to pass in that information and get a percentage value back. Now, the implementer or the contract can actually decide whether to round down or up as well. Okay. Okay, so next we're going to go to state, and we only need to add a little bit here. There's a lot going on there. Kind of ignore that for now. I'm also going to move this down because I prefer to have all the state types listed at the bottom. Makes life a little bit easier to read, since it doesn't matter where this stuff goes. So we're going to define that royalties info that we returned, that we're going to need to save at contract level when we instantiate. There we go. And we need to define that somewhere. Or is it CosmWasm standard? Okay, there we go. Decimal. So where have we got to so far? So we've defined a message, we've defined our queries, although we haven't written our handlers for the queries. We'll write those in a minute. And we've defined our state. So we need to finish off the message part. So the message we're dealing with is the instantiate message. So we're going to finish off the message part by writing the bit of code that writes to this royalties info when we instantiate the contract, okay? Okay, let's just bump this up in size a little bit because we're now looking at this code quite closely. So, right, the first thing that I've done is I've actually gone and written some unit tests calling the functions that we know that we're going to need in a minute that are defined by the EIP spec. Sorry about the train passing outside. So if we run that unit test function again, it's going to say that there's some functions not found, and we are going to add them. But the first thing we're going to do is we're going to change the behavior of instantiate. That's the hook we need to actually write our state, which we've just added. So the first thing that we are going to need to do there is to add we're going to do several things, but we need to add payment address and all of that stuff that was defined in the message type that we added, which was royalties info. You might recall we defined it in state just a minute ago. So the first thing, let's set the payment address and validate it. Now, this is actually a little bit wrong. I'm going to say that as I'm typing it. I don't want to get too bogged down into the fact there's no nulls in Rust. So the reality is, right, that so this our royalties info. Let's have a look at the state. It's got these 3 fields in it. So just a minute ago we defined them as like a decimal, an address and a Boolean, it's actually a U32 because we're going to pass it in. And essentially, what we want to do with these is only react, only send something back, I suppose, if this Boolean here is true. So the reality is defining these two it doesn't really mean anything if this one's false, right? So these should be an option type. And in the version of this contract that's actually going to be like live on the internet that you can go see, you will see that, yeah, they are going to be, they will be an option type. But for now, let's just use these concrete types because it's a little bit easier to work with. And it's a bit easier to show what's going on when you don't have to worry about handling options. If you're curious about them, like I say, go see the live code and there will be a link in the description to that. So all we're going to do here is validate the address, and that's going to be, what is it, message royalty payment address. That's the one. And then we want to define a royalty payment struct. Let's call it royalties info. So it's a classic example, actually, the changing the types of this. Of I think about 5 minutes ago or whatever, I said, oh, I haven't really thought about this too much, and then you go away and think about it for like a minute, and you're like, yeah, it shouldn't be a decimal. It should in fact just be a concrete number, because then we can turn it into a proper percentage and use it for maths later. It actually comes out of, this is a good thing about, it's a good habit actually to get into writing unit tests for this reason. So you can see down here, where's an example of this? Somewhere in minting, yeah, probably there, throwing, yes, there's all the errors that we saw when we ran the test a minute ago. So there's a minting test. No, that's not it. Yeah, so we were setting up the contract and we're passing in these arguments here. And as soon as I started writing this, I kind of realized that the types were wrong. Before, obviously they all still error because we haven't actually implemented the functions yet. But as soon as you do that, and then you say, okay, well, so this function here, right, it mints an NFT, and then we just basically test that if it was immediately sold and we immediately wanted to look up what the royalties info was for that, it was immediately correct at 1 million UGNO to 100,000 UGNO, right? So obviously it's going to error at the moment because this function isn't yet implemented. But as soon as you start doing this, you look at the maths you need to do and you're like, oh, okay, well, the types weren't right. Anyway, back to the matter at hand. So we've defined our struct here, and it's probably going to complain because that's not actually present in the scope. So where would it be? It'd be here. And that's going to stop it complaining. Okay, cool. And then we need to save that. So, which is this magic incantation. We pass in depth storage, which we've gone over as sort of like our database. That's what's being stored on chain. That's info, and the question mark is basically just syntactic sugar for erroring. And it's going to complain. Good. You can see it here. Okay. All right, that seems to be happy with that. Cool. Might again make that even bigger for you. Just because we're about to do an even more finicky bit of code. So what have we done at this point? We've done the instantiation code, so now it's writing royalties info to storage. Now we need to query it out, don't we? So we're going to define that here. I'm surprised this isn't actually throwing an error at the moment. It probably will if we built in the terminal throw an error saying this is not exhaustive because it's not matching on a couple of our cases. So we need to define a couple of query message matches. So first for royalty info, which you may recall in message, wherever that is, over here. It takes a token ID and a sale price. Sale price is a coin. And we're going to match that with to binary. Oh no, don't need to do that. Need to do that though. So that same function that it's complaining about not existing, we know that essentially the name there is pinched from the EIP spec, hence why I knew ahead of time that's what I was going to call it. Okay, and what we should find here, we need to do that, yep. Okay, so let's see if that succeeds. Well, succeeds after a fashion. It errors because that doesn't exist yet, but it's not complaining about anything else, so we'll get to that in a minute. What was the other one called? Query message, check royalties, that's it. And it takes no arguments, and we match that with to binary, and let's be very imaginative and call that check. No, let's spell it right, shall we? Check royalties, depths, and there we go. And that's probably also going to complain. It should complain anyway. Right. Okay. So now we need to implement the query handlers that are going to return the right stuff, and this should make the test pass. Except it probably won't, because I'm quite fat-fingered and I'll probably make a mistake. So let's do check royalties first because it's way simpler. Check royalties, and it took just depths, didn't it? And then it's a query function, so it'll be standard result, and then it'll be check royalties. What's it called? Response in the message.rs. Check royalties response. Okay. Check royalties response looks good. Okay. So that should now stop complaining. It will stop complaining up there and start complaining down here because that is not imported. So, okay. So let's just get the data out of storage. Load depths.storage again. And then, okay. And that's a Boolean, and it should shut it up. Okay, let's shut it up. Good. Okay, query royalties info is the next one we need to write. So this one's going to be a little bit more involved. So pub fn query royalties info. So what I'm going to do here is I'm going to write it so that it sort of works, but it fails the unit tests initially. It's a good sense check for checking that you've actually implemented it correctly when it does, because basically the test should fail, then you implement it correctly, then they should pass. Pretty simple. Yeah.
That's about all I got to say about that. It's test-driven development is the name of the programming pattern if you're not familiar with it. And I'm not the most dogmatic by any means about it, but there are times and places when it's useful. This seems like one of them. So it's going to complain, and it's going to complain about a lot of things. Coin, yes, we haven't got that yet. Let's put it in here. Coin. So the other coin we saw was a helper. Okay, that we're going to use in a second. So, in fact, let's just do it in line. Oh, that's interesting. Okay. Yeah, all right, I know. I'm about to add them. Chill out. Okay, so we're going to return a coin. As you recall, that's the type on the return type down there. Royalty amount coin. Address is a string, so we're serializing out an address from storage. So so sale price is going to be validated as a coin as well, so we don't have a denomination. And okay, and that comes in as a uint. So if we do that function, it should shut it up. Okay, cool. Now you may notice I've not implemented this correctly yet, so we'll hopefully see this run but fail. Or maybe we won't, maybe it'll error for other reasons. No, okay, it fails. Good, these are the tests that we changed. So we can see we've got some unit tests here that are testing the amounts, and none of them line up. So we used an example earlier where the percentage royalty was set at 10%. That's this one here, minting. And we can see left royalties response is 1 million. And this one here is 100,000. So the expectation is that these two should be equal, right? And this one should be 100,000, but that one's 1 million. Now, a bit of elementary maths should tell you that's 10 times that. So this is the percentage, this is the royalty that should be paid, right? And it's instead returning the full amount. And that's because we didn't implement it yet, right? But you can confirm this by, what line is that on? 449. So you can see the assertion here. The royalty amount is set 100,000, and queries royalty info should match this. Queried royalties info is going to our function there, and yeah, it's basically just coming back with exactly the number that we sent in, which makes sense because we haven't implemented it yet. So to implement this little bit of logic, we're going to make a percentage, and it's going to complain because we haven't imported this yet, from royalty percentage. And this is again the thing I was saying about how these are going to be option types, which means that in the future you'll have to check that this actually exists. But for now, because it's just a concrete type, we don't have to worry about that. What is it? Sale price dot amount dot you. Yeah, it's exactly the same as we had on the line below, basically, isn't it? I think that's right. So then we just replace that with this. Ooh, oh right, okay, I haven't done that yet. Use percentage. Oh, the other thing we've done actually, I did it in between the wiggles on the videos. I actually renamed the entire thing. So it wasn't just contract wide, but had the word royalties in the end because it makes more sense. Anyway, cool. I think that's right. And I'll also add a comment that I wrote elsewhere just to clarify what's going on here. So it's going to round down. If we look at the unit tests, you'll see that some of those unit tests are going to round to a fractional number, a floating point number, and the unit test that in every case it rounds down whether it's past 0.5 or not, because that's the default behavior here that we specify. That's what we've decided. But the specification says it can be either, so that's up to you really. Now the only thing left for us to do is to check the unit tests. So let's see if they pass. Moment of truth. Hey, look, it's litre clock. 1337. Cool. Okay, unit test pass. Happy days. So, what have we seen here? We've seen the entire flow from defining a message, defining the storage, and querying out from that storage. We've defined some additional logic, just a little bit of percentage stuff, and although I kind of sort of just did it, dumped it in and told you it existed, briefly I've shown you as well that there's some unit testing going on there as well. So the final things that we can do for this, we've run the unit tests, we can check that everything builds correctly. I mean, it will do because we just run the unit tests and that also does a build, and we can check the schemas build, which is cargo schema, which isn't a given, but they do build. So there we are. Now our work is done and we can push that code. So that's it for this video. If you've got any questions, drop them below. There's still 3 weeks left of Hack Juno. So if you're interested in writing smart contracts, you should get involved with that. Link to Discord is in the description. If you've got any suggestions for future videos, then again, please drop a comment down below. Apart from that, party on, stay safe out there.